Today we'll start with a topic called as error control codes, the codes which can control the error, and in which we are going to see two important methods. One is called as block code and one is called as convolution code. Okay, so let's start with today's topic. Today's topic will be error control codes, and in that we are going to see the following contents. So first we'll see what are the types of error control codes. Then in that types, we will see what do you mean by block code. Then we'll see application of block code. Then we'll see what is a convolutional code. Then we'll see application of a convolutional code. Okay. So here to start with, for types of error control codes. So there are two important types. One type is called as block code and the another type is called as convolution code. These are error control code. Error control means what? You can detect the error and you can also correct the error. So anyhow, you're going to control the error at the receiver. Okay. Then which method does what and how much it can go ahead with detection and correction that we can see. Okay. So out of these two method, we will start with the first method, what is called as block code method. Okay. So here, if you see the definition for block code, it is very simple. Block coding refers to the technique. Remember this. Block coding refers to the technique of adding extra bits to a digital world. That means you are adding extra bits to the information bits. Okay. This is added in order to improve the reliability of transmission because the transmission reliability should be good. It should be error free. We are going to try that. And to do that, at the transmitter only, we are going to add some extra binary bits to the information bits. Okay. So the word consists of the message bits, that is the information bits, plus the code bits, which are called as check bits. Okay. So the a combination of message plus extra bits, that is information plus check bits, or you can call it as message plus code bits. Okay. So information bits, and along with information bits, you will be having certain code bits. So that we are going to send from the transmitter. Okay. A block code adds to existing message bits or blocks independently of adjacent blocks. Okay. So it will add the bits, the extra bits which are added to the information or blocks are independent to their blocks which are next to them. Okay. So for every block, you can add some extra bits. This is what a block code method says. Okay. Then if you go to see the block code, okay, then how you are going to make that block. Say for example, this is the data block what you have shown here. Okay, so this data block is say your message bits, your message bits. Okay, and the number of message bits is say k. There are k number of bits. Okay, then to that, the a channel encoder has to add this. A channel encoder has to add certain extra bits. Those will not be information bits, but they are added in order to look into the error at the receiver. Okay. After you add these certain extra bits, which are called as check bits. Okay. Check bits. There we are going to add R number of check bits. We are going to add R number of check bits. Then automatically the code word at the output will become message bits plus check bits. Okay, so say if your message bits are so many, this is your message bits. Okay, message bits, and say you're adding certain extra bits, which will be your check bits or the code bits. This is your check bits. Okay, message bits, this we will denote as k number of bits, and check bits we will denote as r number of bits. Okay. Now total k plus r will be called as n number of bits. N number of bits, where n is equal to k bits of the message plus r bits of the extra whatever you are going to add. That will be the code word. So here you have shown the code word. So it is n bits long, where n is equal to what? It is message plus check bits, k plus r. Okay. So this is how you are going to have the means you are going to add the extra bits, number of bits to the message bits. Okay. So the information bit stream is divided into blocks. First, you're going to divide the information into blocks of bits. And for every block, each block, you are going to add certain extra check bits. Okay. Now, these coded bits are modulated and sent over a channel. And after you receive it as a receiver, the reverse process of that is done. Okay. Now, how this code word looks like, you will see. Now, here again, I have shown the a code word will look like. These are your number of n bits. So these are your number of n bits, total n bits. Okay, so these are your number of n bits. Now, what this n bits have, you are having k message bits, k message bits, and you are having r check bits, r number of check bits. R number of check bits. So here we have given that n is equal to k plus r. This n is equal to message bits plus the check bits. Okay. So here in the description below we have told the figure shows the block code representation. Okay. So this is a block of information, one block of information. The longer information is broken down into many blocks. So this is one block of information to which you are adding certain extra bits. Okay. So here n is equal to k plus r. This is what we have shown, where n is equal to total number of bits and k is equal to message bits and r is equal to check bits. The n bit block is called as a code word. Now this block plus addition of extra bits will be called as code word. So this is complete a code word. Okay. Now this word you are going to modulate and send it to the receiver. Clear? Now what is the use of this addition of extra bits? The use of this addition of extra bits is we want to detect the error and we also want to correct the error. So our aim is to detect the error, where the error has happened, where 1 has become 0 or 0 has become 1, whatever it is, where the error has happened or detection position, and we also want to try to correct the error. So there will be different methods which come under block codes. Okay. But the general idea of block code is same, that to the message bits of a particular block you are going to add extra bits which will be called as check bits. Okay. So here as an example we have shown, if there are k message bits, then we are going to add r check bits. Then k plus r will be your code word, and that will be having n number of bits, which is equal to k bits plus r bits. Okay. Now here at the receiver, okay, whenever you send this data after addition of extra bits at the receiver, the check bits are used to verify the information. The check bits means the extra bits, the R number of extra bits, whatever you have sent along with the K bits, are used to verify the information. Block codes can be designed to either detect or correct errors. Okay, so block codes, there are many methods in block codes. We will give examples also afterwards. But in that, these methods can either detect or correct errors. Okay, so detection of errors also is possible, or correction of errors also is possible. Block codes are good. They are very good for error detection. More than error or correction, this method of block codes is very good for error detection. It will identify where the error has occurred. Okay. Because data are normally retransmitted in blocks. Okay. Because of that, they are very good for error detection. Now, these block codes, we can have some certain methods under these block codes, and those examples I have are given here. One is binary cyclic code, BCC. and one is Hamming code. So these are examples of block codes. These use the a general idea of block code that along with information you're going to add certain extra bits, and those extra bits will help you at the receiver to detect the error. Okay, so that is what happens in these codes. So you can detect the error, and to some extent, you can also correct the errors depending on the method which you are going to use. So detection and correction both are possible, but mostly block codes are good for error detection. Okay, and as an example of block code, you can have binary cyclic code (BCC) and you can have Hamming codes. Okay, these are just two examples of block code method. Then if you go to see applications of block codes, okay, they can be used for error control coding. They can be used in satellite communication. They can be used to improve semiconductor memories. They can be used in earlier mobile communication systems. The earlier mobile or communication systems, in that also you can use them. Okay. So this was a general explanation of what was block code. That only thing in that is you are going to add certain extra bits to every block of data. Okay. Your complete information will be broken into blocks first, and every block, say for example every block, each block is having k number of bits. You're going to add certain extra bits to them, and those extra bits will be taken along with the information bits, modulated and sent to the receiver. At the receiver, when you receive the signal, examining the extra bits with some method, with some procedure, okay, you're going to identify the error which is there in the received message. Okay, then we'll go to see what do you mean by the next type of coding, which is called as a convolutional coding. Okay, now here if you see the definition, a convolutional coding is a widely used coding method which is not based on blocks of bits. Okay, now here you are not going to have a complete information. See, this is your complete information bits. Okay, this is your information, and information you are going to put into blocks. This is block 1, this is block 2, this is block 3, block 4, and in every block you have k bits. Okay, you're not going to do this. You're not going to have your blocks of information here. Okay, now here see the definition. A convolutional coding is a widely used coding method. A convolutional coding is a widely used coding method which is not based on blocks or bits, but rather the output code bits are determined by logic operations. This is very important. The output code bits are determined by logic operations on the present bit. The present bit, how they are entering, in that only we are going to have, or we are going to operate them with some logic operation, especially XOR gate operation. Okay, this XOR gate operation will be done on a present bit stream and a small number of previous bits. Okay, so this will be clear to you once we see the diagram for it. Okay, so here little theory on what is a convolutional code before we go to the diagram. You can see that a convolutional code is another type of error correcting code where the output bits are obtained by performing a desired logical operation. Now here logical operation means we will do XOR operation. XOR operation you have studied in digital electronics. Okay. So XOR operation will be done on a present bit stream along with considering some bits of the previous stream. So how this is done you can understand in the diagram. This a coding technique rather than depending on the block of bits shows a dependency on the bit stream. Okay, so it is not depending on the block of bits. We are not going to we are not going to cut the information into blocks. Here the bit stream will be flowing as usual, and with that bit stream we are going to do certain modification by using some logical operations. It is also a linear code that consists of the shift register. Shift register you have studied in digital electronics, where it is a binary, where it is a temporary memory or device which can shift the data. Okay, so you can have serial shift, you can have a parallel shift. So those were called as shift registers, used for temporarily storing the bits, shifting operation of bits along with XOR logic circuits to give rise to an output code. So here, whenever you hear about a convolutional coding, then one thing should come into your mind, that here you're going to get the input data bit by bit. You're going to enter with the data, and the data will be operated with shift registers along with a operation of XOR logic. And due to these operations, we will add them, we'll do modulo 2 addition, we'll add them, and we will get an output code. So with the information bits only, we will get a separate code which will be sent as the message to the receiver. And at the receiver, you have to do the opposite process and get back the information. Okay. So this is one way of your adjusting or modifying the information bits. So here we will see the method. Okay. So here you can see we have shown two things. The top one is the a convolutional encoder or conventional encoder, what can be called. So this is your convolutional encoder. Okay. And here you're going to have your message bits. Input will be the message bits and the output will be the code bit. So after a convolution coding, what is the output that you will get here? Okay. So how this is happening? Okay. So if you look at this circuit, okay, so in this circuit, you are showing D1 as one of the shift register, which will shift the data by one bit at one time. D2 will be another shift register, and D3 will be another shift register. Okay. Now here, the message bits are going to be input. Okay, so the message bit will be at a rate called as RB. So message input rate will be RB, that is RB bits per second. Okay, now let's say the message is 1010, which is going to enter. Now first this 0 will enter. First this 0 will enter. Okay, once this 0 is entering the first shift register D1, okay, D1, then we are going to do certain operations. Now, initially, before entering the first bit, we have cleared all the shift registers. We have cleared all the shift registers, and now we are going to enter the first bit, which will be called as 0. Okay. Now that 0 will be there in D1, and D2 is cleared because of that it will have 0. D3 also is cleared, because of that also it is having 0. Okay. Now this will be added. Now D1 and D2, you can see D1 is coming here, D2 is coming here, and also D3 is coming here. So the first modulation, that is modulo 2 addition, what you see, this is modulo 2 addition, is output is C1. This output is C1, and that output is given as C1 is equal to D1 added with D2 added with D3. Now this addition is nothing but your XOR gates. This is modulo 2 addition. It is nothing but your XOR gates. Now in XOR gate, what will happen? If you see the XOR gate truth table, if the input are 0, 0, if the input is 0, 1, if the input is 1, 0, if the input is 1, 1, what will happen? Okay. So if the input is 0, 0, okay. Now in this case, your XOR gate will be what? If you remember the logic of XOR gate, if the input is 0, 0, the output will be 0. If the input is 0, 1, the output will be 1. If the input is 1, 0, the output will be 1. If the input is 1, 1, the output will be 0. This is the truth table of XOR gate. Okay. Now this is what is going to take place when you do the modulo 2 addition of 2 bits. Okay. So here, if for C1 we are seeing modulo 2 addition of 3 bits, D1, D2, D3. So first two XOR will be applied, and again the XOR will be applied, and whatever output you will get will be taken as C1. Okay. Similarly, for the second one, you can see here D1 is coming, D1 is coming, and only D1 is there. So C2 will be only D1. Okay, C2 will be only D1. So here C2 will be only D1. Okay, and then the third one you see D1 is coming here, and then you have D2 which is coming here. So it is D1 modulo 2 addition with D2, that is XOR gate with D2. and then this will be your C3, which will be D1 plus D2. So here we have shown C3 is equal to D1 plus D2. Okay. Now here we have taken this data. This data is 1010. First 0 will go into this D1 register. Okay. And that time we will see what is C1, C2, C3. So here you will be having a commutator which will take the output C1 and then it will take the output C2, then it will take the output C3. That means for one input, we are getting three outputs. So if the input rate is RB, then the output rate will be 3RB. Okay. Similarly, now when the next digit will enter here, the first digit which was there in D1 will go to D2. Okay. Now 1 is going to enter in D1 and 0 will enter into D2. Okay. So in that case, again, you will find out what is C1, C2, C3. Then again, the third digit will come here. Then the second digit will go to the second one and the first digit will go to the third one. Okay. Then in that case, again, you're going to see what is C1, C2, C3 here, output. Okay. Then again, the fourth will come here. Then before that, what was there? It will go to the next shift register. Or before that, what was there? It will go to the next shift register. Again, you are going to take C1, C2, C3. Now, this C1, C2, C3 will be taken till the last bit of the data reaches the last shift register. Till it reaches the last shift register, in every time interval, you are going to take these 3 bits. Okay, C1, C2, C3. So what is this C1? What is this C2? What is this C3? So for every 1 bit entering, you will get 3-bit output. So with the information, whatever you are going to have here, with this information, by doing this logic operations and modulo 2 operations, you are going to have a different output, which will be a code block, which will be a convolutional coding block, whatever you will get at the output. And that you are going to send. Okay. So this is a method by which you are going to do convolutional coding. And in this method, we are basically using shift registers and modulo 2 additions where you are going to have XOR operations. Okay. So here you can see the definition for that. The major elements of a convolutional coding technique includes the shift register that acts as temporary storage and whose stored bits undergo shifting using a sliding window, a logic circuit that performs modulo 2 addition incorporating XOR function. So XOR function is been applied whenever you do that modulo 2 addition. So if you are going to see what are the applications of a convolution codes, then it can be used in voice band modems. It can be used in GSM mobile phones. It can be used in satellite and military communication devices. Okay. Thank you, students.